Okay, we left off, this is 8.5 for Secondary Math 3 Honors, 3.5 for IB Math. So we left off kind of comparing these expansions with the Pascal's triangle. And the last one is, there's a 4 here. So on the fourth row, these are the coefficients. That's right there. So 1, 4, 6, 4, 1. So without even really multiplying out the next one, we can kind of follow the pattern of what's been happening. So now we're in the fifth row. So our coefficients are going to be 1. And then what's happening with the x and y's is this one, the first piece, the x, is raised to the exponent itself. So x to the 5th. And we have y to not a y, so y to the 0. And then we're going to add to that something with x to the 4th. We're decreasing each time and increasing the y's. Y to the 1st plus x cubed y squared plus x squared, I didn't leave enough room, y cubed plus x y to the 4th plus something y to the 5th. And then the coefficients for that are just these numbers right here. So I have a 5, then a 10, and a 10, and a 5, and a 1. So we didn't even really need to multiply this out. So this is one way to kind of do a binomial expansion. Another thing that I kind of want to talk about before we really dive into this is some notation on factorials. So a factorial, it's with the exclamation point, and it just means take all the numbers and multiply up to n. And then we also have a rule that 0 factorial is 1, and you can make, or you can watch some videos on why that happens. And then we have something called a combination, or it's sometimes referred to as the binomial coefficient. And it's written either like this or like this. So NCR or NR. So it's like a fraction, but it doesn't have the line. And that is just follows this formula. Now, I don't need you to memorize this, and I don't need you to use this ever. We're going to be using our calculator. But to kind of show you if this is what it's talking about, 7 is my n, and where'd that green one go? The r is 3. So if I were to kind of write out this formula, I have the n, which is 7. So I want 7 factorial, and then 7 minus r, which is 3 factorial, and 3 factorial. And this is just kind of a way to count how many objects can be in a specific order, that kind of thing, if you're choosing objects to work through something. So you can go look up stuff more on the probability and statistics stuff. But basically this is just going to be 7 factorial, so 7, 6, 5, 4, 3, 2, 1 over 4 factorial, 4, 3, 2, 1 times 3 factorial, 3, 2, 1. And then you just simplify. So the 3 2 1s reduce, the 4s can reduce, 3 times 2 is the same as 6, so that can go away. And then I end up with just 7 times 5 divided by 1. Okay, you can also do that on your calculator, and I have the steps written out right here. So if we're doing these ones, we're going to do Let me see if I can make that brighter. It's a little bit brighter. So we first want to list out the n value, which is the 4. And then we hit math, go over to the probabilities section, and it's the third one, NCR. You also do have a factorial button. So NCR, and then it wants you to type the R, so in this case it's 0. So I hit a 0, and then I hit enter. So this reduces to 1 right here. And then we're going to add to that something. And they're mowing the lawn out there. It's better than a screaming baby. So I'm going to go and pull this back. And the only thing I need to change is that now we're doing a 1. So now that's a 4. So then this piece is a 4. And then I'm going to type this in again so you can kind of see what's going on. So I'm going to hit 4. And then it's math, go over to the probabilities, NCR, hit enter. And then I want a 2. And then we're also going to need when it's a 3. And we're also going to need when it's a 4. So this is saying this number is a 6. This number, we already used that color, is a 4. And this number is a 1. And then you just add those together. So I get 8 plus 2, which is 10, plus 6 is 16. So that is evaluated. The thing I want you to notice is those numbers showed up somewhere else. On Pascal's triangle, row 4, 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And that's why it's called the binomial coefficient, is because these are the coefficients. So even if you don't memorize Pascal's triangle, you can still use this. Okay, the baby is waking up because she's always waking up because she doesn't sleep anymore. I'm going to pause the video. So the binomial theorem is this right here. Let's see if I can get the paper to stay. But basically, it's if you have a binomial raised to an exponent and you need to expand it, you take the summation from 0 to whatever number this is, and all it's saying is you take your first piece and have it be the highest exponent. So in our previous case it was, and I don't know what I did with the papers, like x to the 4th, and then x cubed, and then x, so on. So you're taking your first piece, highest exponent, and slowly decreasing it by 1. This one, you are slowly increasing it by 1. Bless you, baby. And then these are the binomial coefficients, or the numbers from Pascal's triangle. So to kind of work through something, for example, on this first one, my A value is going to be x. The B value is going to be -2. And then the, let's find another color, N is going to be 5 from right there. So we can write it out horizontally, but I find that it's easiest to write it out vertically and then write your answer horizontally. So I'm going to basically start writing this out as some binomial coefficient, and R is going to change. So in this first one, we're going to have an N and an R, N and an R, N and an R, 3, 4, 5, 6 is what we're going to need. Okay. So the N doesn't change, so that's always going to be 5. The R changes though, so I'm going to use red for R. I didn't plan that out. So the first time we're going to go through this, we're going to have RB0. Then we have RB1, and then 2, and then 3, and then 4, and then 5. And then my A term, and I also have the B term. And then this stuff right here is basically just saying take N minus R. So take 5 minus 0 and you have 5. I never actually think about it in that way though. I just say, well, this one starts at 5, this one starts at 0, so the maximum and the minimum. And then I just kind of decrease this one, increase this one. So 4, 3, 2, 1, 0, 1, or 0, 1, 2, 3, 4, 5. Okay. Then I actually work through this. So the binomial coefficient, if I type that into the calculator, is going to be the 5th row of Pascal's triangle. So I'm not going to show you typing it into the calculator because I'm only using one hand right now. But when you do type it in, just like we did up at the previous one, we're going to get a 1, and then we get 5, 10, 10, 5, 1. Okay, and then for our x, this is just, our x doesn't really do much. It's x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, and then x to the 0 power is just 1. Then I have my -2 to the 0 power is just 1. -2 to the 1st is -2. -2 squared is 4. -2 cubed is -8. -2 to the 4th is 16. And -2 to the 5th is -32. And then you just simplify all of that. So my answer is going to be, and I'm kind of out of room. Let me see if I have a piece of paper I can write on. Yeah, I'll do this. So basically I'm going to have x to the 5th times 1 times 1. And then -2 times 5 times x to the 4th is -10 x to the 4th. And then 4 times 10 is a positive 40 x cubed. And then 8, or -8 times 10 is -80 x squared. And then 5 times 16, what is 5 times 16? 80. So then I have a positive 80x, and then 1 times -32. So that is expanded. Now, you could have just done this. One, 2, 3, 4, 5, yeah, and multiplied that all the way through, and that's going to give you the same thing. But there is kind of method to, or reason to understanding this method beyond just binomial expansion. It shows up quite a bit. So I'm not going to take the time to go over something like this one because it's the same concept. You just have more things to multiply, and I want to focus on sum of, well, no, I am going to do it. Okay, so I'm just going to do it on a, I'm not going to do it. Change my mind. I'm just going to show you what I've done in the past. So you have 4 choose 0, 4 choose 1, 4 2, 4 3, 4 4. Okay? And then you take your 2x to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0. And then you take your negative 3y, 0, 1, 2, 3, 4. To simplify that, you get 1, 4, 6, 4, 1. Either type that into the calculator or use Pascal's triangle. 2x to the 4th, that 2 gets raised to the 4th as well, so you get 16x to the 4th. And it just kind of simplifies this way. And then you have all of these. So the binomial coefficients don't actually translate to the direct coefficients down here because there's other numbers that are happening. But that's kind of how this is set up. So, going forward, we're going to apply this in a little bit of a different way than what we've done in the past with the secondary Math 3 honors class. So I'm actually going to do that in a separate video so that anybody that remembers everything about the binomial expansion, they can skip to it.